This is track 4 for Wednesday in the Palace 2, New Trends in FastFlux Networks.
Okay. Thanks, Charlie. Yeah? Okay. So we did some research on the FastFlux domain. We see some new trends, so we want to show here. So what we used to know, here show is the FastFlux network, right? The left side, it showed a normal web request and response as normal things. On the right side, it's a FastFlux network. There is a layer of proxy. The infected PC over here is using as a proxy. The way, by doing this, bad guy can hide themselves, right? You have no way to find where they really is. So by using the DNS, response, that they frequently changing the IP of their domain, they can provide a pretty good high availability over there. So imagine there's a tons of infected PC over there. So another thing we know is we call it the double FastFlux, right? The left side shows the single FastFlux. The malicious name server housing a bulletproof server. The right side shows the double FastFlux. The reason they do the double FastFlux is they even want to hide in their malicious name server. You have no way to know where is their malicious name server. Oops. Okay, so give a summary here. So FastFlux malicious domain is they used to deliver malicious content. They have layers of proxy over there, either in the web server or for protection for the name server. They're changing their IP frequently. The IP location is, the geolocation is very diverse because their infected PC could be anywhere. So why they do that, I just already mentioned. The major thing is that they want to hide themselves. Also, they want to provide a high availability. Okay. Recently we did a research. We want to see what happened to the FastFlux domain right now. So during that 6 months research, we found some new stuff. It's pretty interesting. First, we found, FastFlux domain is not that fast anymore. It's become much slower. Second things, besides, double FastFlux, we found something we called unflux. Third, we found, another interesting is, it used to be when you visit a malware domain, a FastFlux malware domain, it may return you a set of IP. So right now, every time you visit them, they return you only one IP. Why? Finally, we do some research on we tracking thousands of FastFlux domain. We found there are many things shared between them. They're sharing the IP, they're sharing the name servers. So the most interesting of our research is clustering. We have thousands of malicious domain. We try to classify them to the different cluster to find some interesting stuff. So we will talk about details.
Okay, so let's dive into the details. The first thing, Xinran also mentioned the slower change rate. So what do we mean by slower? Before, from the 2008 NDSS paper, the FastFlux domain's changing rate is less than 10 minutes per IP. That means for each IP, they only use them for less than 10 minutes. But based on what we find, more than 80% of FastFlux domains actually currently use one IP address longer than half an hour. And the average number is actually over an hour. You can see the detailed number in the table below. So the question you ask is why? Why slower? Well, it's always about the money. Because the infected hosts are becoming more valuable. And that means that's the one actually hosting the malicious content. That's the returned IP addresses. And on the other hand, the domains are becoming disposable. There's a comparison of registration of domain, the cost of registration of domain. Like around less than 10 years ago, it cost like, more than 10 years ago. Sorry, it cost like $100 per year. And currently only costs like $10 per year. So attacker can register a lot of malicious domains and they don't really pay that much attention to them if they got blocked or disabled. But they do pay attention to infected hosts because they are valuable assets. And therefore, the conclusion is that if you think as an attacker, you don't really need to change it so far. As long as this IP still can provide valid malicious content, it's okay. And they try to expose only a small part of their botnet because that's their infrastructure. That's how they make money. And they can run these infrastructures to different campaigns. So for each individual campaigns, they don't need to give you all the botnet. Plus, they want to avoid detections. So let's talk about sharing. First, we noticed that sharing is pretty much everywhere among different campaigns, among different FastFlux domains. For example, we noticed that inter-domains, inter-different malware families, inter-different malware families, the IP addresses are shared. And they also, on top of IP addresses, they also shared authoritative name server. So the table here lists some details. For example, on average, you can see both the IP addresses and the authoritative name servers has been shared by more than 4 different domains. So why the sharing again? So it's also about money because the infected host, which is the returned IP addresses, the valuable assets, as we mentioned before, it's part of the attacker's way to make money. And the authoritative name servers also commonly hosted on what we call bulletproof hosting. And that's going to cost a lot of money. So they're not going to use the authoritative name server only for one purpose or one task. So it's for rent. For different campaigns, different purpose, they will rent authoritative name servers multiple times. And so is the IP addresses. However, we noticed that most of these FastFlux domains, they don't really have a dedicated name server, meaning that if you really do an NS query on these FastFlux domains, you will get a lot of NS record in the DNS response. And all those DNS, like over 70% of those appeared to be name servers. They actually host on the same IP address that's actually returned as part of the A record, meaning the host that actually hosts the malicious content behave the same as the name server. So let's talk about the detail how they share things. We noticed there are 2 levels of sharing. The first level is that the IP address are shared among different FastFlux domains. And how they do this, they use the authoritative name server as a control point. So authoritative name server will give you the real DNS response that will actually point you to the content provider, in this case, the infected host. For example, there's some data here. We collect 12, 13 authoritative name server. Each one hosts from 2 to 15 different FastFlux domains. And the number of IP shared between those FastFlux domains, you can see the number is pretty high. Most of them are above 90%. The second level, we call it shared among different authoritative name servers. For example, those 2 are actually served as the authoritative name server for a lot of FastFlux domains. And you can see this is the whois information of those 2 name servers. The IP addresses of one of their name servers are actually shared. Another thing we dig into is inter-malware family IP sharing. By inter-malware family here, we only use high-level idea of family. For example, we differentiate different 4 types of Trojan malware family. Also, we compare them with the general term spam malware family. So from here, you can see the spam, they shares a lot of IP addresses. Why? They almost share half of the IP addresses because for a spam campaign, they often focus on the same topic. For example, we all know the pharmaceuticals ones, the dating ones, the financial ones. So when they serve the same topic, they register a bunch of different domains, and all those domains share these IP addresses because they provide the same content. However, for Trojan, different Trojans serve different purposes, so the sharing rate is much lower. It's around 10 to 20%. The third thing we notice is what we call it unflux. It's just something appears to be unflux. We already know double flux. So for this unflux, what it shows is that if you do a DNS query, for example, in this case, on the lastcore.com, it will give you NS record, like ns1.lastcore.com. So if you keep digging, okay, what's the NS record for this one? It will give it to you ns1.ns1.lastcore record, and this can go on, go on, go on. So what does this tell us? If you're really looking at the A record, shows that all those like high levels of name servers actually resolve to the same IP addresses. That's what we mentioned before. So on those infected hosts, they not only serve as the content provider, they also serve as a name server. How they do the name server thing? They use a wildcard name server. So whatever you query, they will just give you they add another NS layer on top of that to make it appear as the legitimate NS returns. But in fact, they are not. The first thing we call it one IP at a time. So this doesn't sound reasonable, right? For FastFlux domains, each time they just return one IP address. However, the time to leave number here is 0. So this actually gives the attacker more control. The total number of IP addresses is less than the case of the old FastFlux domains, which use like round-robin fashion, each time give you a list of different IPs. In this case, an attacker can control what kind of IP address to return in a timely fashion, so that they can notify the local DNS cache, and they can avoid detection. For example, attacker only know this infected host has been blocked something, and they can give you a new one. If this one can work, it will continue working on this one. And the last thing we're working on, and the most interesting part, is the clustering. So if we use one sentence to summarize this, it will go like this. Bad domains like to hang out together, like this. This is the graph we extracted from our research. Like Xinran mentioned, we track thousands of different FastFlux domains, and we try to connect them together based on the connection I will explain later. Here in this graph, each node is actually a FastFlux domain, and the edge between different nodes means the connection between those nodes. And the larger node meaning they map to more different infected hosts, different IPs. So clearly, you can see here is the cluster, here is the cluster, here is the cluster, here's a large one, loosely connected, here, here, here. So the clustering is obvious. So how do we use this? First, let's see how these domains are actually connected. The criteria we use to build this graph, the clustering graph, is these things. First, the content similarity, because they have to serve the similar purpose to provide the similar content. The second thing is the shared IP addresses. So if like 90% of IP addresses, more than 90% IP addresses are shared between two domains, it's very likely that they actually serve the same purpose. The third one is shared name servers, because the IP address and also name servers is like part of a package provided by those players in the underground economy. So they will, when you have a campaign, when you have a task, when you try to rent that kind of services, they will give you, okay, I will give you like how many different IPs, and I will make you to use this name server. And the last one is name similarity. Believe it or not, sometimes just by looking at the name, you know they probably serve the same purpose. For example, in this cluster, this one here, this one is actually this cluster. So you probably cannot read all of them all the names here very clearly, but they all start with stating something. Another interesting thing is that they not only form a cluster like self-contained, there's also some inter-cluster connections. So why is this possible? Because the migration of clusters. So like we mentioned before, the infrastructures of this infected host and the bulletproof name servers are for sale. They are for sale for different campaigns. And if some of the infrastructures are being exposed, and possibly being blocked, because we already identified some of the IPs are victim IP or infected hosts, so we'll block them. So as part of the service, attacker will give his customers other new IP addresses, like move them. And this type of new IP addresses very likely being used by other campaigns, other purposes, so there's a connection over there. And from this figure, you can see very clear, there's like 2 nodes. Those nodes means the FastFlux domains. That's actually a connection between this cluster and this cluster. So the reason is that for those two nodes, the return IP address is actually being shared by both clusters. So that's how they connect together. This connection actually shows us very clear that this infrastructure, whatever infrastructure the attackers offer, has been served on different purposes and probably at the same time. So what we can learn from this cluster? The first thing we can learn is that we can discover the purpose. Because sometimes by only looking at the content of the web page, I mean, for spam it's easy, right? Just by looking at the content, you know what the spam is trying to do. But for other things, sometimes it just give you like benign looking content. You don't really know what they're trying to do. But based on clustering, if some of the domains has been visited by a specific malware samples and you have some knowledge about that malware samples, you know what it's trying to do, and you will infer the rest of the domains in the cluster because they all serve the same purpose. The second thing is we can learn underground structures as we showed before. The clustering one, we know what's where are the infected hosts, how they connect to each other, which are the authoritative name server, the bulletproof name servers. We can identify all those entities in this big graph. The third one is we can track family because, like we mentioned before, the returned IP addresses for the malware domain for a campaign is not static. They like a migration from one set of IP address to another set of IP addresses. So we can track that migration so we can provide more like in timely detection. And the last one is we build reputation entities. Some of the entities like the IP addresses and the authoritative name servers, they are valuable assets, so they will be used longer. They will be served on different purposes. So if we can spot them in the first purpose, we will know, okay, whenever we saw them later, we will know they are bad, and whatever domains has connection with them, probably bad. Also, we can find new FastFlux domains just by looking at the new domains that has connection with the existing clusters. So the last part is also very interesting. So what looks like FastFlux but not? There's many things. So here we have 3 examples. The first one is distributed services. We all know NTP. So actually, if you do a DNS query on this domain, the pool NTP org, you will get different IP addresses returned. And all these behaviors fit perfectly in the existing FastFlux domain detection algorithm or heuristics. Another very interesting is Bitcoin DNS seed. It's part of Bitcoin peer discovery protocol. So if you do a DNS query on these domains, it will give you, like each time, give you a list of different IPs, which is the peers, Bitcoin peers around you. In this case, actually, we find this guy has been mapped to over 7,000 different IPs in just one day. Another thing, the second example is the censorship bypass. So, for example, the most famous one is dynamic internet technologies. So it's try to bypass some of the things from the Chinese government. So they use the FastFlux look like DNS returns that each time it gives you different IPs to reach for one of their proxies. The characteristics of this benign FastFlux, because we have to somehow understand them to differentiate them from the bad ones, is that first they have very faster changing rate, like old FastFlux, but not like new ones. The second one is that they are all for high vulnerabilities. The table here shows you the numbered average, each IP being used how long. So this number is much lower than the current number for FastFlux domains we listed in the very beginning. So what can we learn here? I think the most important lecture is fast is no longer a keyword in FastFlux. A few words about how we collect data. It's actually, so first we have a candidate site, FastFlux domains candidate. We collect those domains from our samples. We collect them from public source and also from recent domains because a domain has to be registered first before they can be used. After that, we do active monitor, meaning we will actively, periodically do a DNS query on those domains on all the major DNS providers. And with all the DNS responses, we do aggregation on those data. So what about defense? because we know all the tricks might not work. We cannot apply the changing rate rule. We cannot apply the multiple geodiversity resolved IP rule. So, like we mentioned before, from clustering, we have the repetition score on assorted name servers, which will be used across different FastFlux domains. Also, something we noticed appeared unflux structures. And the last one is the cluster-based detection. Like we mentioned, one of the purposes of the clustering those FastFlux domains is to find new FastFlux domains as long as we can find the connections of this one to the existing clusters. Okay, so that's pretty much all the talk. Thank you. Yes.
How do you track clusters as they change over time?
I'm sorry.
So I have two questions. But first, what clustering algorithm are you using to pull out clusters from those graphs you showed? And second, how do you map clusters as they change over time? Whether that's a Parsean method.
Yeah, okay, thank you. For the first one, for the clustering, first we take the connections. So we find the strongly connections and we set up a threshold, like how strong cluster you guys connected together as a cluster. So that's the high-level idea. For the second one, how do we use cluster? Is that what you're asking?
I'm wondering,
How to-
our problem right is if we cluster at one time slice, right, and then move a time step forward and then cluster again, how are you mapping between the clusters at t+1 versus the clusters?
Exactly. We consider the historical records that has been accumulated up to this point. You do the clustering, because if the campaign migrate, right? So they're starting at the first set of clustering and mostly based on the IP addresses to return the content. And when they migrate, like in the next time slot, they still have the majority of the things in common. So if you look back in the history, if they're really related, this is what we discovered, they will have the majority part in similarity. Yes, I think, we can only take like one more question. So if you have more, we can do it like offline. Yes, please. Yes, actually we have a list of dynamic DNS, but we have excluded those from these FastFlux domains. Thank you.